Hello, my name is Peter Leeson. I'm a consultant in management culture change with some 45 years experience in information technology and some 25 years in other areas in consulting and helping companies grow and solve their issues. Over the past few years, a lot of organizations have moved to Agile, believing that this was going to be the solution to all their problems, and have rapidly found out that they still have the same problems. They turned to Agile because they were late, they were going over budget, they were not delivering the quality that was expected, and after they had implemented Agile practices and processes, they found out they were still late and they were still delivering doubtful quality and not actually solving the problems that they were hoping. So what I would like to do over the next few minutes is give you a brief talk as to why this happens. Why didn't Agile solve any problem? Why didn't it actually deliver as promised? What I'm going to do is I'm going to start with some history and then talk about team management in general, the complexity of managing teams, and then go more clearly into what is Agile, what is included, what it actually means. Let me start with some history. So, life cycles were critical. Okay, it started very early on. It was understood that if I want to deliver a product, I've got to implement a number of practices, get them in time, get them managed. It's part of the normal organization of any company. Now, when building a hardware object, a motor car or something like that, it's fairly obvious that some things can be done in parallel and some things need to be done in the right sequence. And so this is basically what happened when in the 1960s, 70s, 80s, we were trying to find out what was the best way to build something as intangible as software products. And it was understood, okay, we need to isolate the requirements, understand what is being accepted, put in place a general design as to how everything will fit together, and then start building out the various components and take a section of the product and decide what has to be done, what has to be built, and actually do it, test it, make sure it works, and then integrate the result into something that can be quantified, demonstrated to the customer, and accepted as a product that satisfies their objectives and move into operation. The concept evolved over times, and very soon there was something developed that was called the spiral model. The idea of the spiral model is that it's not as simple that I can design everything and then develop it, but I've got to go through a number of continuous phases. And communication, understanding what it is the customer wants, what are the priorities, what has to happen, planning what we are going to do, perform risk analysis, develop the product, install, support it, and get feedback from the customer before starting the same cycle again. And the idea is that by a continuously cycle, we can slowly grow the product, add things to it, and there's a clear understanding that every entry point is separate from the corresponding engineering. The engineering phase has a sequence, has its own life cycle, and happens at a specific moment. Most important in this was the risk analysis, and something very important, which was the decision at every cycle that we should continue or should we stop with this development? Have we spent too much money? Are we sending good money after bad? There has to be this risk analysis. What have we spent? What is come out of it? Are we in the good direction, or do we need to revisit things? The third generation of life cycles can be called, if I may call it that, would be the Agile development process. And the Agile development process means a number of practices that allow us to continuously develop and deliver parts of the product, continuously add value to the customer, and get feedback. And this is done on fairly short cycles of 1 to 4 weeks. It is the natural follow-on from the spiral model, with 2 new activities that have been restricting its capabilities. One is the idea of bringing the delivery phase down to a very short phase. And the second one, if you notice this does not actually have a go, no-go decision. We will continue practicing. Now, both the predictive life cycles, which is the traditional approach of defining everything we're going to do and doing it, and the incremental life cycles have got obvious advantages and disadvantages. The predictive life cycle has got well-defined phases, simple milestones. There's a complete list of what needs to be done. The plan is there. We can start developing the test cases from the start. Acceptance criteria are included in the requirements. All these things are well established at the front. Disadvantage is that it's only when the product is finished that we can decide if it is satisfactory or not. By having everything planned up front, we are getting the illusion of predictability. It is not as predictable as it appears. Things could go wrong. Requirements change, and when a requirement changes, it becomes a confrontation. It becomes an argument as to what should be done. The incremental life cycle allows these aspects to be corrected, because even though we are doing the analysis up front, we are partitioning the risk, and we are continuously working with an architecture that allows ongoing comments from the customer, acceptance. We can start testing fairly early on in the life cycle. As soon as something has been built, we don't have to wait until it's completed. There's some disadvantages, of course, is that doesn't suit every system, and very often the system requirements are not completed before starting. So I'm not talking here about the detailed requirements in the product, which can evolve. And of course, the scheduling, the staffing becomes complicated as we don't quite know where things are going. Overhead costs are pushed up fairly quickly. Continuous changing is not something that facilitates funding, and the change process often deteriorates into rapid building a product, testing it, fixing it, rather than truly understanding what needs to be. And of course, people get tired of the continuous changes. We need to have, for an incremental delivery such as the Agile one, we need to have clear understanding of the priorities, the dependencies, the relationship, and we need to understand the cost of iterative processing. This is not coming for free. We need to take the time to prioritize requirements, understand the value they have for the customer, and partition them according to what are those values. We need to understand what is going to be in each delivery. How is this adding value to the client's product, to the client's business? And of course, you have to plan this from the beginning. It is not something that happens on an ongoing basis. The problem with Agile practices is that they are largely team-focused. So we are looking at the productivity of a team rather than what is possible for a business. The estimates are based on the team's understanding of complexity, of performance, of productivity, and so on. And of course, there is little understanding of the overall value flow of the organization. It is focused very much on the engineering value. So if we're focusing on the team understanding, we need to understand what it is that the team is doing. And we need to be able to manage the team accordingly. There are different levels of team management that need to be considered. Some teams need to have a lot of direction, a lot of management. Some teams, we can't just let things happen because they know what they're doing. This largely corresponds to the state of your team. So you've probably all heard of the concept of form, storm, norm, perform, in which a team progresses. The first question is, why are we here? What are we trying to do? Who are you? Why should you do this and not me? What's my role in this? We come to the storm mode, where team members start arguing as to, why are you doing that? I should be doing that. This is my responsibility. Stop interfering. I can do this better than you. So there's arguments starting in the team, and slowly we get to the point where the team is normal and is working, and then slowly they learn to grow and trust each other, and we get into the high performance team. Now, each one of these levels requires its own type of management. So if I'm in a forming team, I need a lot more defining, planning, teaching. So I got to continuously manage the team. A storming team, I need to clarify things. I need to redirect. I need to stop things that are going wrong, but also encourage and praise them. A normal team, we're collaborating, it's working, I can reassure them. I can facilitate problem solving rather than having to solve the problems myself. And finally, at the performing level, I can trust, empower, and challenge the team. They know what they're doing it correctly. I can just let them happen. It's important to understand the different levels because we are naturally aimed at solving our own problems. We're designed to take on our own challenges and control our destiny. By overmanaging a capable team, you will be motivated. And yet by undermanaging a startup team, you're going to lose them. And so we need to understand what is the right level to manage the team. And we need to understand how this impacts the complexity of the environment. Complex means difficult to understand. Simple means easy to understand. Simplistic is too simple. Okay? Simplistic sounds, it's always nice. But if you put a simplistic solution to a complex problem, you are creating chaos. You are making things worse than they were to start with. So you need to understand what is the level of complexity that you are dealing with before you start working on an engineering activity, whatever it is. If it's simple, you need very little management. If it's complex, you need a lot more management. You need to understand that there are variations in the team skills and in the level of complexity of your projects, of your engineering work. And you need to understand what is the right level in order to decide where to go. Okay, it's easy to accept the obvious easy solution. But the obvious easy solution only works if you've got an obvious easy problem. You need to understand what is the level of problem you're looking at and then adapt the solution you want to give based on the level of complexity and the level of skill of the product. For years we've been pushing system thinking, and system thinking focuses on the whole system, on getting the solution done, and is often so ideal that it fails. Complexity thinking is saying, okay, let's do this one step at a time. Let's take a step, identify the direction without overstating the goal, and discover what is working well, what is working bad, so that we can proceed this way. An added advantage of complexity thinking is that you've got the chance to listen to the cynics who will tell you why it's not going to work before you try it out. This brings a lot of value, but that's another discussion. Engineering is complex today. Most engineering organizations fall into the chaotic issue when they try to fit old solutions, simple theories, to new problems or complex situations. So you want to try to identify the potential solutions to bring to a complicated state. So you want to understand it as you proceed. In other words, you want to try something, verify, validate it, progress, and loop on it. And that continuous looping. Now that sounds a lot like what Agile is promoting too. So what exactly is Agile? What does it mean? The Agile manifesto, which started this all off, was a very simple statement. We're uncovering better ways of developing software by doing it and helping others do it. We've come to value individuals over process and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to challenge over following a plan. In other words, the basis of the Agile Manifesto was saying results are more important than planning. There is value on the items on the right. We value the items on the left more. That is an important statement. The items on the right have got value, which must not be ignored. Individuals in interaction are more important than process, but process is still important. It has to be there. So talking about Agile, there were 12 principles that were established. I've replaced the word software here by engineering of products because it's more general by now. Highest priority is to satisfy the customer. That sounds good. Early and continuous delivery of valuable results. We want to welcome changing requirements even late in the development process to harness change in order to satisfy the customer's competitive advantage. We want to help the customer. We are there to help them. Deliver work products frequently. From a couple of weeks to a couple of months, the shorter the time scale, the better. We want to continuously deliver something to the customer that adds value to them. Business people and developers, customers and engineers must work together daily through the project. Projects are built around motivated individuals. They need the environment and the support they need, and they need to be trusted. So working together means I want to have this continual interaction between the engineers and the customer and the end user. I want people who are motivated and trusted, not micromanaged. I've hired these people, I've taken them on because they know how to do it, because they know how to do their job. I now need to trust them to do it correctly. The most efficient and effective method for conveying information is face-to-face conversation. Talk to people. It's not emails. It's not Slack or Zoom. It is actually meeting up with people and talking. Progress is measured through working products rather than through ticking boxes in a plan. Agile processes promote sustainable development. In other words, we want a constant pace that can be maintained indefinitely rather than rushing through in order to meet deadlines, exhausting people, demotivating them. Continuous attention to technical excellence and good design enhances agility. Architecture and design are critical to making it happen. Simplicity, the art of maximizing the amount of work not done, is essential. It's not the amount of hours you put into it, it is the amount of work you do or do not do. Best architectures, requires and designs emerge from self-organizing teams. Let the team decide themselves who is doing what and how they relate to one another and how things happen. And at regular interval, the team reflects on how to become more effective, tunes and adjusts its behavior. So there's a continuous concept of identifying what worked, what didn't work. There's one word I will challenge in this, and that is the use of the word continuous at the beginning. I think that they actually meant continual. In other words, we're doing a bit, we're repeating it. We don't really want continuous delivery without interruption or cessation. That is valid in very few companies, such as Amazon, where they are continuously updating their website and their formula and the way they judge what you want or what you could buy. But that is not what most companies want. They want regular updates. Now, when I ask people in the field what Agile means, I get answers that are largely related to tools and techniques. Okay, so Agile is pair programming, extreme programming, sprints, retrospective user stories. That's not what Agile is. Agile is something a lot more subtle than that. Agile is values, principles, culture, commitment. It is a desire to move on fast. It's a predictable delivery of values, self-discipline, self-organization, and continuous improvement. It's not a tool, it is a state of mind. The practice, the tool you are using, is less important than understanding the reason why you are using it. Now in Agile, they have ceremonies. Okay? The ceremonies, the word is badly chosen to start with. Ceremonies are things that usually bring little value except general comfort to the people conducting the ceremonies. They are formal acts, and they very often replace the value by sticking to the ceremony, to the process. In other words, rather than following Agile practices, technologies, and ceremonies, understand the level of competence of the team you are working with, adapt the level of management and the structure accordingly, understand the criticality that the product has for the customers, and adapt the controls and the plannings accordingly, and understand what is necessary, the complexity of the product you are doing, and pick the approach accordingly. If you do this and understand different levels of approaches you can take, you can always adapt the right approach. Doing Agile because you do Agile does not work. Agile is a set of values. It is not prescriptive. The focus is on maximum value for minimal output. Focus on outcomes, not on output. Focus on products, not on hours spent. Value needs to be defined if it's going to be achieved. Product teams, real users, need to communicate continually and do as little work as possible in order to achieve the result. Imposing Agile introduces a conflict with the values and principles that underlie Agile methods. So that's what I wanted to talk to you about. That's my overview. Thank you. I hope it brought some value to you. My name's Peter Leeson. Please feel free to contact me. You can contact me at info@pleeson.co.uk or through my website at Orchestrated Knowledge on LinkedIn. I'm happy to answer any questions. Thank you for your attention.